Welcome back to the lesson on limits, and this time we're looking at the limit as x approaches 1 of this rational expression. As you can see here, we have radicals involved in both numerator and denominator. And by direct substitution, that's what we try first, remember, we get that the square root of 1 plus 3, which will be 2, minus the square root of 2 times 1, which is also 2, divided by the square root of 1 plus 8, which is 3, minus the square root of 2 times 1 plus 7, which is also 3, will give the value of this entire expression, rational expression, 0 over 0. And because the denominator is 0, obviously this is undefined. So we're going to say that this is an indeterminate limit at x equals 1. Now, another thing we discover by direct substitution is the fact that the numerator had a value of 0 at x equals 1, and the denominator had a value of 0 at x equals 1. So what that means is that, based on the factor and remainder theorem, when the value of the expression is 0 at a specific x value, it means that x minus that specific x value, which means x minus 1 in our case, must be a factor in the numerator and obviously a factor in the denominator as well. So our job now is to make this indeterminate form limit estimatable or evaluatable by removing x minus 1, because that's what makes it undefined at 1, by factoring x minus 1 from both of them. And obviously when you see that you have square roots, it means that we first have to release x from the roots because x is hosted inside the roots. And to get the x outside the roots means that we need to eliminate the radicals from the numerator and obviously from the denominator as well. Now, the method that we use to release the terms from the radicals is what we call rationalizing. And because we have radicals and both sides of this rational expression, that means we have to rationalize both the numerator and the denominator. Now, we perform rationalizing the rational expression that contains radicals by using what we call the conjugates or the conjugation method. So what that means is that we will have to multiply by the conjugate of the numerator, both the numerator and the denominator. So this is how it's going to work. So this is our numerator. Whoopsie. We'll have to multiply the numerator by its conjugate. Now, remember that the conjugate would be exact same, the conjugate of this binomial would be the exact same binomial, but instead of minus, we'll have to use the opposite. So x plus 3 and 2 root x in here. And instead of a minus, we'll have to have a plus. If we had a plus in here, then the conjugate would have had a minus, right? So since we're multiplying by a new expression, which will have certain value, that means that we have changed the function itself, so the entire function inside the limit. So we have to multiply by the denominator by the same thing in order to maintain the value of the function inside the limit. So in this way, we have simply multiplied by number 1, right? Which doesn't change the value of the function inside it. Now, in a similar way, we will have to multiply the denominator by its conjugate so that we can eliminate the roots. And the conjugate of this denominator would be the root of x plus 8. Again, the exact same thing we see here, right? So the exact same binomial, but instead of a minus, we'll have to choose to write a plus here because we need to write the opposite of it, right? And again, since we're multiplying the denominator by it, we got to do the same thing to the numerator. Now, As you can see here, we multiplied this function inside the limit by the conjugate of the numerator and conjugate of the denominator. We call this double conjugation. So this is evaluating limits by conjugating both numerator and denominator. So let's check and see how this will turn out now. So we're going to start simplifying. So we'll write limit as x approaches 1, which we have to write all the time. Now I'm going to draw a long, long line because I'm going to have a big fraction here. So it's party time. So we are multiplying the conjugates together. Remember that what we see here is 1, 2, 3 different factors which are in the numerator. And the only factors that we're interested in expanding are the ones that are conjugates of each other. Again, we know the reason. We want to get x out of the radicals. So I'm going to show all the steps in here. But obviously there are steps that you can skip. I'm going to mention them hopefully by the end of the video. So we have x plus 3 squared minus 2 root x squared. So these together will make the product of these two conjugates. I'll keep them inside the brackets, obviously, because we have a binomial here, so there are two terms. And we have to write the other factor, which is the root of x plus 8 plus the root of 2x plus 7. And I will close the brackets here. We'll continue with denominator. So in the denominator, we are multiplying the two conjugates. Again, we have 1, 2, 3 factors. The only ones we expand and simplify, or the only ones that we multiply with each other, are the conjugates because, again, we are trying to get x out of the root. So we have x plus 8, square root of x plus 8 squared, minus square root of 2x plus 7 squared. Close the brackets. And this will make the product of these two. And we have to write the other factor as well, which is the root of x plus 3 plus 2 root x. Now, a reminder that these two factors will not change until the very end when we evaluate, when we substitute x by 1. So we'll keep on writing them the way they are in every step. So the only part we're working with is this, because we want to simplify until we get x minus 1 as a common factor. So we have a little bit of work to do, so be patient. It's not difficult work, but it's just large volume work. So here we go, big fraction again. So when we apply a power of 2 to a square root, the square root will disappear because remember the square root is nothing but an exponent of a half. So 1/2 times 2 is 1, right? So it's x plus 3 to the power of 1. So I'll write x plus 3 here. And here we have 2 root x to the power of 2. And I'm going to stop for a second. There is a common mistake that I notice we make, and it's a very easy mistake to make, as a matter of fact. Now, the power of 2 will apply to both the coefficient 2 and the square root. So, 2 to the power of 2 will give a 4. And the square root of x to the power of 2 will give an x. So, the common mistake that I see we make most often is forgetting to bring number 2 to the power of 2. We are so focused on doing the roots and we forget that this is pretty powerful itself. So we'll continue with the denominator. I'm only focusing myself on the simplifying part of the expression. So we have again x plus 8 here and then minus. And here I'm going to stop one more second again. So the square root, power of 2, will eliminate each other. But remember that here we're minusing a binomial. And when you minus a binomial, it means that every term inside it is being minused. So minus 2x minus 7. And it is a very common mistake for people to make and write negative 2x plus 7. So they give the negative to 2x and forget the 7. Please don't. And to make sure, keep 2x plus 7 in brackets if necessary. And this entire thing will make one factor here. So I will highlight them so I won't miss them. And again, with practice, you become a lot faster at doing this. So at simplifying, at skipping steps, right? Reasonably. So we still need to show our work. So 2x plus 7, and then we have down here the root of x plus 3. You know what, I'm going to make the roots close at some point here. So here we go. And here we are, we're getting closer to simplifying this entire thing. So simplify the factor x plus 3 minus 4x. That will give negative x and then negative 3x plus 3. Now, down in the denominator, we'll have x plus 8 minus 2x minus 7. So obviously, I'm keeping those in brackets. I will still highlight them just to be sure. So that's the limit as x approaches 1. And now I'm writing the tedious part. Not tedious really, but the part that doesn't really change. I just have to write it. And again, when we rewrite actually parts of the expression that aren't changing, mistakes happen sometimes in how you transfer the terms because we're not paying attention and we do this in a very automatic, robotic way. And we may transfer the terms, when we transfer the terms, we may make a mistake. So watch out for that. Always stay focused. So here we go. Now we have the limit. As x approaches 1, I'm going to write my fraction in here, long fraction. Now, and I'm going to stop for a moment and think, so what was my main goal in here? I want to get x minus 1 to be a common factor to both numerator and denominator, so I'll keep an eye on that. So what I see here in the numerator is negative 3x plus 3, which means I can take negative 3 out. And then we have x minus 1 in brackets. And take a look at the denominator. We have x minus 2x, negative x, and 8 minus 7 is plus 1. So that will stay in brackets. It goes together. And again, I'm going to rewrite the part that doesn't change. Root of x plus 8 plus root of 2x plus 7 divided by root of x plus 3 plus 2 root x. And here we go. Now, I'm getting very close to, simplifying in here because there is not much more that we can do. But I noticed that here I do have x minus 1. I'm excited about it. But when I look at the denominator, I don't quite have x minus 1. But as you notice in here, the terms in these binomials are pretty much the same, but they have opposite signs respectively. So when they do have opposite signs, it means that they do have a common factor. So that's the limit as x approaches 1. So we get negative 3x minus 1. Take out negative 1 from negative x plus 1. So there we go, finally. And let's write one more time. Root of x plus 8 plus root of 2x plus 7 over root of x plus 3 plus 2 root x. And close the brackets. So now we're ready to simplify. This is exciting. Ready? So chop, chop. So they simplify. And another thing they probably need to take care of is negative 3 divided by negative 1. That would be positive 3. And you know what? I'm going to take one more step to rewrite this limit in the most simplified form possible before evaluating it. So that would be the limit as x approaches 1. Big fraction again. So we have positive 3, so remember, and the square root of x plus 8 plus the square root of 2x plus 7, close brackets, the square root of x plus 3 plus 2 root x. So we're ready to substitute x by 1. Drum rolls. Let's see what happens. So we have 3 And we have root of 1 plus 8 plus square root of 2 times 1 plus 7 over square root of 1 plus 3 plus 2 root 1. So again, we're going to have 3 here. So let's take a look at this. So root of 1 plus 8 is a 3. Root of 2 times 1 plus 7, that's root 9. So that's a 3 as well. So we have 3 plus 3, 6, divided by 1 plus 3 square rooted, that's a 2. 2 root 1, that's a 2. 2 plus 2, 4. So that's a 4 down here. So 3 times 6 is 18. And 18 over 4 will simplify to 9 over 2, and that would be the limit of this function at x equals 1. So you have one example down here that you can try on your own, have fun, and double check the solutions with the notes posted online in our classroom. I hope this made sense, and thank you for learning with me. Have a great day.